Physicists have created the most sensitive strain sensor ever made. Biotechnology Materials Science, University of Sussex. Filtering electron microscopy. Filtering electron microscopy, SEM, image of G-balls under high amplification. College of Sussex. Touchy strain sensor created that can detect the weight of a feather. The sensor, created by the Materials Physics Group at the University of Sussex, can extend up to multiple times higher strain than strain measures as of now available and show obstruction changes multiple times higher than the most touchy materials in research improvement. The examination group accepts the sensors could carry new degrees of affectability to wearable tech, estimating patients' crucial signs, and to frameworks checking structures and extensions underlying honesty. G-balls glass vial. Photo of G-balls resting in a glass vial. Each ball has a delicate polydimethylsiloxane (PDMS) center and is covered with minuscule sheets of graphene. Marcus O'Mara, from the School of Mathematical and Physical Sciences at the University of Sussex, said, "The following flood of strain-detecting innovation utilizes flexible materials like elastic instilled with conductive materials, for example, graphene or silver nanoparticles, and has been being developed for longer than 10 years at this point. We accept these sensors are a major advance forward." When contrasted with both direct and non-straight strain sensors referred to in the logical writing, our sensors display the biggest outright change in opposition at any point detailed. Alan Dalton, professor of experimental physics at the University of Sussex, said, "This promising innovation may demonstrate particularly valuable in set-up fields like medical care, sports execution checking, and quickly developing fields like delicate mechanical technology. Our exploration has created modest, versatile well-being observing gadgets that can be aligned to gauge everything from human joint movement to vitals checking. Numerous gadgets could be utilized across the body of a patient, associated remotely and conveying together to give a live, portable well-being diagnostics for a portion of the current expense." The new paper, distributed in the diary Advanced Functional Materials, subtleties the cycle for consolidating enormous amounts of graphene nanosheets into a PDMS framework in an organized, controllable style that outcomes in great electromechanical properties. The creators say the technique can possibly be stretched out to a wide scope of two-dimensional layered materials and polymer grids. The sensors convey enormously improved conductivity at all deliberate stacking levels with no evident permeation limit. Business check gadgets experience the ill effects of moderately low affectability and strain range, with measure factors going from 2 to 5 and most extreme strains of 5% strain or less, bringing about the opposition expanding by under 25% and forestalling high strain detecting needed for real movement observing. The new sensors can identify strains under 0.1%, because of their higher check factor of approximately 20, and up to 80% strain, where the remarkable reaction prompts the opposition changing by a factor of more than 1 million. This permits both high affectability low strain detecting for beat checking and high strain estimation of chest movement and joint bowing because of the record obstruction change. Super sensitive strain sensor. Extending and curving the super delicate strain sensors. Credit: University of Sussex. Dr. Sean Ogilvie, Research Fellow in Materials Physics at the University of Sussex, said, "Business strain sensors, regularly dependent on metal foil measures, favor precision and unwavering quality over affectability and strain range. Nanocomposites are appealing contender for cutting-edge strain sensors because of their flexibility. However, inescapable reception by industry has been hampered by non-direct impacts, for example, hysteresis and creep because of the fluid-like nature of polymers at the nanoscale, which makes precise, repeatable strain readouts a continuous test. Our sensors sink into a rehashed, unsurprising example which implies that we can in any case remove a precise readout of strain regardless of these impacts. The work was made conceivable with the help of US-based Elastic Organization Alliance." Jason Risner, VP of Sales and Marketing at Alliance, said, "Coalition has a long history of development and we must assume a functioning part in driving edge elastic innovation that utilizes a troublesome nanomaterial like graphene. It is important that we cooperate with logical pioneers like Professor Alan Dalton at the University of Sussex. We are excited to see the items that might actually emerge from our association. Graphene is a bewildering material that can reform our lives. Our organization is glad to be on the bleeding edge of something so new."